are now the eccentrics, and these go into the holes into here. Well, we are missing something here. Of course, late job. And that's what we are going to do today. Two eccentrics. So yeah, this has to be turned into a suitable size and shape. First things first, I haven't been talking about safety issues in the lately, but these are mandatory. There is no excuse not to wear them. Well, I have noticed that I forget them quite often, and that's not a very good thing because accidents don't come with a bell in their neck. So yeah, well, that's it then. Of course you don't need any dangling clothes or anything like that. Yeah, okay. So I have turned these jaws in order to get this comfortably into there. Let's tighten it one more time. This needs to stay there. This was tight. 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 Yeah. I think we are running this, we should try to run this about 600. I don't want to. Okay, it's okay. And then I'm using this VNMG tool first to face it. So now let's touch it first. Well, now I'm trying to get a good surface finish here because this is going to be our final surface here. So, I'm running this at the same speed, about 600 RPM, and I'm no more feeding it manually. It will be 0.076 millimeters per revolution. And this tool, this bit is different. It's now Cermet with a very nice round corner. And I'm peeling off about 0.1 millimeters here. Well, let's see now. You probably noticed I raised the speed. Yeah, and it's silky smooth. Yeah. So, now I have here a boring bar. Like that. This is upside down because I need to reach into there. And this is the only tool that I can go near enough here. Well, okay. But we need to limit the travel from this surface to the shoulder. It should be 20.1 millimeters. Well, I will first cut 20 millimeters there. And after that, the last 0.1 I do differently. Well, now the first thing is to put this tool into contact with, let me show you, put this into contact with the workpiece surface very gently. I can feel it here in the wheel. Now it is in contact and it's really just gently there. Well, of course I have locked the compound and everything, so this is not used in this case. So now when the blade is there, we zero this one. This is my travel indicator. It's in zero. So then I retract this from the surface, away from there. Okay. And then this is the carriage stop. I put it against there and tension it even so slightly so that I can still move it, but it gives me some resistance. And then I dial here 20. So that was 10. Let's check that everything is alright there. Yeah. Well, let's put it into a place where everything is really right. So that's 15. And there is really some resistance here. Wow. Maybe, oh, well, yeah, okay. That's quite exactly 20. And then I tighten this. Yeah. There you are. And now, well, now it's just to turn this. It will stop. Yeah. There you go. Let's put this so that it's almost on your way. Because this is throwing, well, it's throwing the chips all over the place. And then it produces these hot worms, hot snakes. This is because the material is really tough. It's well, it's tough. And I'm advancing here 0.5 millimeter, and then we go again. Wow, but the surface is really nice. Now we should have 1/10 of a millimeter to go, but I want to be sure of this. Yeah. Well, if I take 1/10, I end up being, well, a little bit too loose. So it should be almost 1/10. So something like 7.5 microns, no, 75 microns. How can I do this? That should be our place now. That is our final cut, and after this we should be ready with this. I will move this to exact 0 so I know where to go. Yeah, the surface is really nice. It looks a little bit grey, but well, I don't know. Okay. Yeah, if you can see from there, it's exactly what I aimed it to be. So now it's 38.95. Okay, now let's turn the jaws. What? The oil screw. I cannot do it now because these jaws are stumbling. I have to do it later. So, well, the workpiece of course burst away from there. There you are. Wow. Wow. Let's put it there. And then the jaws. First one. There you are. And I want this to be something like 47 millimeters. Yeah, it's 62. Okay. So, let's see. Well, now it should be 47. Remember, our goal, the final diameter for this is 45. So, and yeah, I hope you can see this so that it focuses also. It's quite near 47. And now I just turn it around. And now let's turn it around. So, well, here. Now it should fit more comfortably than the earlier time because, yeah, really. I put it about there. Wow. Pull it back very slowly, like that. There you are. Now it should be as straight as it can be. I will zoom you nearer so you can see what is this. Okay, this is my normal parting tool, and that was filled with stuff. So, and this is the Torx. Is it like this? Smaller. I bought this as new, and yeah, that's the one. A Torx Man. Okay. So we'll take the blade out, and then I have these are made by Iskar. I found these from a flea market, and if you can see, it has it's not straight at all. It's like that, but it doesn't fit into that tool holder, so I need to use some construction here. That fits well, but then I need to put something here in between, and that's actually the correct width. And now just push it against there and then tighten it there. There you are. We have a grooving tool. Okay, setting the correct place for the groove. The groove should be measured from this surface. It should be 10.1 millimeters away. The center of the groove. Okay, let's do that. So let's put the blade against the workpiece, and the width of this blade is 4 millimeters. So I compensate here 2 millimeters, like that. That should be it. If I now go, yeah, 10.1. Then that's 10.1. There. Well, yeah, you can, the accuracy of that device is 0.1 millimeters. So, there you are. Well, of course not with this speed. We need way less speed. That's probably alright. Then we need cutting fluid. And well, yeah, let's see. Probably a little bit high. It doesn't want to grip into there. Well, this means that I need to fix my parting plate after this. I need to lower it down just a tad. Let's try that. Because it needed well, probably the blade is dull. So let's see about this. I need to do everything again, but such is life. Let's see. For the first height of this tool. Well, it's way high. Okay, that explains. It was really high, like 5 millimeters. That's bad. And that explains. Can we align with well, 10.1. Yeah. I didn't lose it. So now it should cut more freely. Let's see. Yeah. Huge difference. Yeah, this is just for creation. Groove for creation. have a groove for creation. Yeah. Well, it became like this. A groove. We have a groove. Well, now facing this to dimension actually. This is all set up. Yeah, okay, let's see. Yeah, it's really smooth. Okay, and now it should be 3 millimeters. Quite exactly, actually. Doesn't deviate too much. And now I will make the same for this surface, and now I don't know how to, well, I know how to, I just need to do this really gently. So, now it should be straight enough for that kind of operations. And apply again. At least it's shiny. This should be a perfect fit into this hole. That's, well, it is really perfect. Let's see, just a drop of oil into there, and let's see if this now fits here. I also used my Dremel to get, there was a lot of burr-like things. Yeah. Oh man, that's not good. That's too much. Why? What did I do wrong? Is my dimensions, my dimensions, well, it's a perfect fit otherwise. Oh man, but why this? Wait a minute. Yeah, 17.10, not 20. This is now 20. 70. Can I face it? That's really bad. That's bad. Wow. Well, the chips come out blue. Hot snakes, really. Well, I finally solved the riddle of chip breaking here. It's actually the speed. If the speed is like 600, the chips become blue and then they become really long, not good. So now I'm running this at about 300 RPM. My feed is 0.152 millimeters per revolution. The cut-off depth is half a millimeter from diameter, so 0.25 from each side. And the chips become about this long. Yeah. Let's see now. This should be 38.90 whatever. Well, 95 seems. 38.95. Quite exactly that. Well, here is now the place for this groove. Well, let's make it. There is a broom. This workpiece. First I will now dial it in into there. And Okay, that's okay. Tighten it there. We have a very steady base for our dial indicator. And then I put this here, this. And then we have our dial indicator. Just planning here. Okay, like that. And like that. Oh, okay, it's about in the middle. And then let's turn it so that you can see it. Well, I should also be able to see it. So let's see that we can rotate these now, and we cannot. Well, now we are there. And it's about, the tip is not, it's tilted. Well, it's tilted. Why not make it straight the same way? Now it's about straight. And as you can see, this is really steady. Of course, I can push it, but it always returns to the same point. This kind of dial indicator stand is one of the best. Okay, now the next step here is to find the minimum. Well, it's way off. There is our minimum. Like there. And then let's see if it's over one turn. And it is. Okay, that's high. So I need to just put it coarsely there first. Let's loosen this one here. This would be a very tedious process if you do it the wrong way. Okay, let's see now. Let's find the minimum again. Well, now it's a lot better. There is our minimum. I put my 0 there. Okay, maybe, yeah, maybe. And then I find the maximum, which is, wow, 50. Okay, so midway is 25. So all what I need to do now is to dial these to 25. Oh, that's the wrong way around. And yeah, this is really like, you can do this in one pass if you are careful enough. There is the 25. Okay, then we go to the next pair of jaws. I put them, okay, like that. And then this one should be a little bit that way. Let's just dial them to 25. That's because that was the midway of the minimum and maximum. Now, well, let's see. As you could see, now we have some very slight deviation there, like 200s. Our midway was not correct, it was not 25, it was something else. There is that now. And then this also a little bit like that. there you are. Well, it's a little bit still. I think this is the side we need to tighten now. And now I will also tighten this for the final. And I don't try to knock this straight. It's straight enough as is. It's not sitting. Oh, okay. This has moved, I think. Yeah. When I purchased this, I didn't. I cleaned it up, this dividing head, and tightened everything. And it's not a loose thing, this. And now you can see it's there. We did dial it in, and it's not a tedious job like in an ordinary four-jaw job, because this is so accurate. And it's, well, you have to have a very steady dial indicator stand. If this would be the ordinary one, it's so easy to stumble into it. And then your measurements are all wrong. Well, I can remove this now. And I can remove this. Well, it's just a T-nut, a very heavy-duty washer, 16mm shank, and well, works like a charm. Oh yeah, and that rod, it's hardened, case hardened, very tough material. Oh well, and now we need to move the dividing head back to here. And now I move this dividing head from here to here. So, well, just loosen it first. Yeah, and you might say that, yeah, now you lose all your settings. Yes, I do. But I have this fence here. I was prepared for this. So let's go here. And then this needs to be way back here. So there is an additional groove here. You might not see it. It's here. These four here. They are also grooves like this, so you can put it really way back here. Now it's quite far away. I have a thing like this. Seems to be straight, and it's leaning against the fence. Yeah, there it is. Just tighten it into place. Reject. Uh-huh. Oh, this is a little bit. Well, now it is. Yeah. And I'm looking for these jaws that I can fit comfortably there. There you are. Now it's positively locked. Doesn't rotate at all when I use this indexing mechanism here. Okay, and now we need to adjust this this thing to a correct position, and this one is pretty easy. You just loosen the brake and then you turn the head, and you have to be really careful not to move it sideways, but just rotate it. And this is actually quite easy with this machine. You can do it like this. And then I search here for 0, index it there, put the brake back on and remove the index. This machine, if you have these series 51, 52 or 53 machines, they have an indexing mechanism for this rotation. And you should always disconnect it after indexing. Because if this catches something, it will try to rotate the head, and if that indexing mechanism is engaged, it might damage it. Yeah, okay. I have not moved the table in Y direction, so we should be good to go. Well, now let's drill. And when you are drilling like this, don't forget this. There are very good chances of bad things happening here. For example, if this rotates, it might bind your drill, and at least my milling machine has enough power to shatter this, and then you have like high-speed steel, which have really high speed. And they are it's better to have one piece of those sticking on your forehead than sticking in your eye. Well, I'm running this about 400 revolutions per minute. Let's see. Yeah. And I'm feeding this manually. Yeah, so let's go. Okay, that was easy enough. Let's take these and put them into the bin. Whoa. You have to be careful, those might be sharp. Yeah, okay. And then I will change something here. So, it's in back gear, so I can loosen it. That. My knocker again, like that. Hopefully, yeah, it comes. That's one of the benefits of this this type of taper. You don't need a lot of room to take them out. So, and you always wipe your drills clean before putting them on your storage. So that's how it should look. Like, this one came with the shower cleaner, and I have suspicions that this also is a shop made, but it's really good. And now again, clean up that and that. Should go there. Does it? Well, we need to lower the table a little bit. Well, 10 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, maybe. No. 5 more. 1, 2, 3, 4, 5. Man, So it was 15. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15 and 15. What I will now do, I will remove this from there. Now it should go quite easily actually. Yeah. Then I put this in free gear so I can rotate this freely. This is really not good. Okay, maybe we can do that. I need some visual reference here. When I tighten this, so I put, there is a flat here, but you can rotate this quite freely. But now I put this here and try to make it level. Oh, man. It's about there. Yeah. And then I tighten it in place, and this is really, it has very tight tolerances, this thing, and while it's now there. Wow. I think we need to back it up somewhat. This is this knob locks the ways and things, so I pull it back like that, and then let's go into the bore and let's touch. This should be sensitive enough so that, yeah, there it is. Put it there. It's not touching yet. Well, I'm adjusting it with this ring now and trying to make it touch. So we are, put it there. It's not yet touching. Now it is touching. And let's see now. Let's put it into a 0 position here. So it takes about, well, 3/10 away from there. Well, and this one I'm feeding with not manually, but using the feeding mechanism. So it will be 17 millimeters per minute, and the speed of the spindle, let's see how it looks like. Well, it doesn't look much because we are on free gear. And now, and this is not enough. Actually, for this type of, I would like to have it like 350 maybe. This is not 350, but when I switch to high gear it is. Yeah, okay. What more? Well, everything should be, we should be ready. This is tight, yeah. And we are at 0. We need to measure it, of course, a few times while doing this, and yeah. Well, let's now measure this one. So first I need to move this so that I can put my measuring stick inside there. So I lower the table 10 turns here. 1, 2, 3, 5, 6, 7, 8, 9 ja 10. So let's put this into there. Oh. So, and then push it up until it, well, not good. Maybe I should move a little bit away that way. Okay, now. Oh yeah, okay. Yeah, now it works. Well, we are 15.27, I think. Oh, 73. Okay, but we are now on 0 with this one. So that's easy. 27. But I don't want to push my luck by dialing everything at once. So I think we can safely take 0.2 millimeters at a time. Let's take a little bit more, like that. And then 10 turns up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I doubt that, but you never know. It didn't make it too big, it made it exactly as intended. Well, yeah. Okay, now milling a flat here in order to be able to drill a hole. That's the flat. Now 6.5 millimeter hole, and it's running about 390 revolutions per minute, and I'm feeding this manually. Making the thread into this blind hole. Well, I aligned this using this 6.5 millimeter drill so that it's sitting straight. Now it's time to get rid of that drill. Now it of course drops. Oh yeah, okay. And then we need this spring-loaded center. There you are. And, I'm going to use this kind of tool because this didn't have the centering hole there, so we can use that one as centering. There you are. Just some lubrication and then we go. Man. Well, yeah, it's somewhat stiff. Yeah, it is. But we get it done. A lot of force is required here. A lot more than I anticipate. Let's take the chips out from there. These chips are also really hard. Okay, we are still not in the bottom. And this, oh, now we are in the bottom. Yeah, there you are. And this was the most dangerous of them all to thread. There you are. Now we go. Hopefully it doesn't break into the hole. It would be disastrous. Because this requires quite a lot of force. I don't like this at all. But what can you do? This is totally different material than... Oh man! We should be already there. Maybe I break the chips a little bit. Yeah, it helped. They started to back into the... Okay, and we are through. Wow! Hopefully in the correct place. Yes, it did. And now we just go through. Yeah, it was a good idea to see what's happening inside there. Yeah, this really is sharp. Oh. Yeah, it's really sharp. It grips. Yeah. Okay. That's done. Well, then we of course have the other piece. It's a very similar process, just we don't have the hole for the handle. Other than that, it's a similar process. Yeah, here. Well, I think we succeeded with this. They are not flawless. They are not perfect as such, but they will do the job as intended. And they fit in their places really well, and that's good. This has some difficulties to go in because, well, of course, because the fit is really tight here. Yeah, there it goes. Yeah. Well, in the next episode, we will be making the shaft that is connecting those eccentrics together. And furthermore, we will be making the handle, a short bar for that one, and well, that's it. It will be really a short episode, the next one, maybe. You never know how many times I need to do those. Well, till then, bye!